Here in this video, we would like to derive an expression for the loss or gain of a time in a pendulum clock. You probably know what I mean by a pendulum clock is there will be a long rod and at the bottom there will be a kind of a circular stuff, and it's like a pendulum who oscillates about its main position basing on which our wall clock works. That kind of a clock is called a pendulum clock. So I can show you how does it looks like. So the pendulum looks like this. At the bottom there may be a small sphere. From the point of suspension, fixed point, to the center of that circular part could be called length of the pendulum. What happens to the time? So this pendulum oscillates about its main position, because of which seconds, hands, minutes, hands move, so that the time is also moving and showing some value. How the time gets affected with respect to temperature, I want to explain first and then derive an equation for that. So let us consider what happens in summer and what happens in winter to this pendulum clock. Let us start with what happens to temperature. In summer temperature increases, in winter temperature decreases. What happens to the length of the pendulum? As temperature increases, that pendulum expands. In winter it compresses, length decreases. Once if the length changes that way, how does the time period of a pendulum changes? We know the time period of a pendulum is 2 pi root L by G. As length increases in summer, time period also increases. But in winter, it decreases. As time period changes, what happens next is, how time period means what? Time taken for one oscillation. Time taken for one oscillation. What happens to the time taken for one oscillation is, as the time period increases, time taken for oscillation also increases. Here, time taken for oscillation decreases. Then what happens to number of oscillations per second, which is also called as frequency? As time taken per oscillation increases, number of oscillations per second decreases in summer, but in winter it happens in a reverse way, it increases. Then what happens to the total time? Here, number of oscillations per second has reduced, so it makes lower oscillations, lesser oscillations. It shows lesser time. Then there is a loss of a time in summer, and there is a gain of the time in winter. So the first thing I want you to understand is, because of the pendulum's temperature variation, in summer there is a loss of time, whereas in winter there is gain of time. Now we want to proceed further and find out how much loss is there or how much gain is there. I want to derive a mathematical equation for that. That's very simple. Basing on time period of a simple pendulum is 2 pi into root of L1 by G at initial temperature T1 degree centigrade. As you increase the temperature to T2, time period also changes, as 2 pi remains the same, length changes and the gravity remains the same. If I make T2 by T1, 2 pi gets cancels, G and G. 2 pi by root of L2 by G by 2 pi root of L1 by G. That is square root of L2 by L1. But L2 is the final length after rising of temperature. That can be found as L2 equal to L1 of 1 plus alpha into delta T. Basing on the definition of alpha. You know the definition of alpha, right? So when you cross multiply them, L2 minus L1 becomes alpha L1 delta T Take that L1 to that side, L1 plus alpha L1 delta t. So L1 is common, 1 plus alpha delta t. That's the reason why L2 is 1 plus alpha delta t. Taking that into consideration, if you want substitute the value of L2 here, you will get a different equation. What happens then? Tell me, find out. T2 by T1 equal to root of L2. In the place of L2, I will write this value. L1 of 1 plus alpha delta t by L1. L1 gets cancelled. So T2 by T1 is under square root. That is whole power of half. Now, as there is a whole power of half, I want to expand using a binomial expansion. X plus y whole power n is nc0 x power n y power 0. nc1 x power n minus 1 y power 1. nc2 x power n minus 2 y power 2 and so on. This binomial expansion that I have learned in the school, I am just trying to apply that here, right? NC0, any NC0 is 1. X is 1. 1 power n is half. Y is alpha delta t power 0. That's the first term. NC1, NC0 is 1. NC1 is n. These are the basics of binomial expansion. NC1 means n, that is equal to half. X power n minus 1 means 1 power 1 by 2 minus 1. Y power half is alpha delta t whole power 1 plus, in the next term, when you say y square, y power 2, I will get an alpha square term. See, have you seen here alpha power 0 in the initial case? Alpha power 0, alpha power 1. Next, I will get alpha power 2. What happens when you get alpha power 2 is, alpha itself is very small for any given material solid, like for iron 11 into 10 power minus 6. Alpha square becomes very small and negligible. So I can ignore these terms further. These terms are ignored. That implies what is remaining. T2 minus T2 by T1 is 1, 1, anything power 0 equal to 1. So the first term is 1. This is half. 1 power anything is 1. Alpha delta t power 1. That's it. So T2 by T1 is 1 plus half alpha delta t. Get that 1 to this side. T2 by T1 minus 1 equal to half alpha delta t. Take LCM, half alpha delta t. So what we have found here is fractional change in loss or gain of the time, change in time by original time equal to half alpha delta t. You can extend that further and find T2 minus T1, who is either a loss of the time or a gain of the time, is half alpha delta t, whatever. Take this T1 to that side, it becomes into T1. So T1 is initial time. How much is that initial time? We shall take it in seconds. That means if you want to calculate the loss or gain of the time per day in a given problem, in the place of T1 you have to write how many seconds are there per day. 24 hours, 60 minutes and 60 seconds. But if you want, say for example, per hour, in place of T1 I will write 60 minutes and 60 seconds. Like that, the value of this T1 will change depending on what is given for you in the problem. This is the way that you can find the loss or gain of the time. So I want you to understand that in summer there is a loss of time, in winter there is a gain of time. By how much? By this much. Loss or gain of the time is half alpha into delta t. Like that we can calculate how much the pendulum loses or gains time with respect to the change in temperature. That's it. Thank you for watching.